Hello, in this tutorial we're going to be using Altium to design a board that links a 4-digit 7-segment display, like the one displayed on the screen here, with a Teensy Arduino. So different than the Arduino, we'll be using Teensy, which is a little bit of a smaller footprint. For any PCB project, you should always be making the circuit itself on a breadboard first, just so you have a proof of concept and you're sure that it works before you dive into it. We do have one in real life, but it's just easier if I show you this one here on this website. But essentially, it's going to look something like this, where you'll have an Arduino linked to the display with some number of resistors in between. Okay, so if we open Altium, then we can get started. So the first thing you want to do is you File, New, Project. We'll name this something like 4-digit 7-segment display. Okay. And then within this project, the first thing we want to make is a schematic. Okay. So if we look back here at this image, there are 3 parts to this circuit. There's the Teensy itself, there are the resistors, and then there's the 7-segment display. I've done a little bit of research as to where and how we're going to generate these components. So the 7-segment display I cannot find online anywhere. Specifically what we're looking for are the Altium files that have the schematic for it, as well as the PCB, or like what that will look like on the PCB. So in this project, or in this video, I'll be showing you how to design your custom components in Altium. The resistors, those are native to Altium, or within one of Altium's included libraries, and so we can just use those. And then for the board itself, for the Teensy, a past 4904 member has made it, and so we're just going to download that from the bot-provoking GitHub. Alright, so we've made our schematic. Let's start with the Teensy. So if we go to the bot-provoking GitHub, and find the repository called Footprints Altium, then we can download it. So there I went code and then download zip. And we save it. We can open our file explorer and we can extract all. This will take a little bit. Okay, once we've extracted, let's go into the folder. Let's find the Teensy 3.2 to 4 folder, and then once you go into there are a couple files. You're going to want to hover over this one, the one with the library package at the end, and we're going to select it and say, actually we're just going to open it. Okay, once you open it, you see in Altium you have this new project open here. We're going to compile the integrated library. Alright, and then once that's done, in our 7-segment display project, we can go to components, and then we're going to change this drop down to Teensy footprint, and then we can just drag it in. Alright, so this is our Teensy. If we look back at the project, there are a couple of other things we need. We need the resistors, and then we need the 7-segment display. The resistors are easy, and that we'll figure that out when we are wiring. So let's work on making the 7-segment display. When you're designing custom components in Altium, it is very important to know 2 things. First, you need to know the pinout of the component, and you should also find the data sheet of the component. So the display we're using, at least for this project, has a serial number CL3641AH, and if you go to the website that produces, then you can find the data sheet like so. And then the pinout, is a little bit harder to find, but it's pretty standard. It is just we're just going to use this image here on the website. So let's make this component. In Altium, you're going to want to go here, you're going to do File, New, and you're going to do Library, Integrated Library. Okay, with this new integrated library, we're going to do Add New to Project, and we're going to say PCB Library. Okay, this will open this folder. So what we're first going to design is the way that the PCB will actually look like on the board. So what is important here is that we have the datasheet in mind. This way we know that, or I guess this way we can set the pins to be the right distance apart so that the drill holes, or the holes that drill through the board, are actually the right distance apart, so that the 7-segment display actually slots in nicely. Okay, so this is the dimensions, and schematic here is in millimeters, and so that's just something to keep in mind. The way I found that was I just converted from millimeters to inches here, and the ratio seemed to be about right. Okay, so going back to Altium, or I guess if we think about what this will actually look like on the board, we have 6 pins across, and then we're going to have 2 layers of them kind of displayed here. So this is this one side view, and this is the other side. We have 6 pins, and then we have two kind of columns of them. So in Altium, we're going to start by saying place pad, and we're going to place one. And then we're going to go to Properties tab with it selected, and we can change around the properties so that it matches the image. Okay, so we toggle to the image. It's literally just going to be kind of two rows of 6. So if we think about, so this circle here is the origin, or kind of 0, 0. And so the pins are 10.16 millimeters apart. And so if we just take half of that, that can be the Y value, and then for the first row, and then the second row can just be the negative of that Y value. So if we do 10.16/2, we get 5.08, so we can set the Y value here. Right here. Sorry, that's the X value. The Y value we can set to 8, and then we have to specify the units are millimeters. And then for the X value, let's just think about the first pin in. The pins are separated by 2.54 millimeters each, and the middle will be between the 2 middle pins, so half of 2.54, which we can just do 1.27. That'll be the first Y value, or X value. My bad. Oh, and I did the wrong units there. We're going to say millimeters. Okay. Now let's think about designators. So if we go to the image here, and we look at the pin out, on the top row, the first to the right is D2. So that's just what we're going to call this pin. Okay. Now let's look at diameter of the hole, or I guess of the pad. if I can find it. Okay, so hole size. The schematic says that the pins are 0.45 millimeters wide. I like to give a little bit of wiggle room, so we can just set the hole diameter to 1 millimeter, just to give us a little bit of extra space. And then for the total diameter of the holes, let's just do 1.406 millimeters. So just a little bit smaller than we have. It just makes the footprint a little nicer. Okay, so that's one pin. We just need to do 12 more. So we can copy, and then we can paste. And then we can just place it and select, and then we can change the properties. So the height here is going to be, what did we say it was? Y is 200 mils. Yes, and then for the X value, we need to add, if we go, so we need to take the X value of this one, and we need to add 2.54 millimeters. So we go back to Altium. I believe there's a feature where we can say maybe I'm not sure that worked. We can just do it here. Um, 1.27 plus 2.4, 3.81. Okay. And then here we need to change the designator. So if we look back at this, we see the second one out is called D3. So we'll just change that to D3. Okay. So then let's just paste. We can do this again. Properties. This will be what did we say? Let's see, 1.27 plus 2.54 times 2, so 6.35. It will be the X value. Y is still 200 mils. Change it to millimeters. Okay. And then let's look at the designator again, B. Properties, B. Let's just check. Okay. Now that we have these three made, we can probably select all three, and we can copy, and then it gives us this X. So this is this green X is where you want the center to be when you copy it. So we're going to just set the center to be the center, and then when we paste, that'll be the center. Okay, and we can just place these, and we can do that. Actually, yeah, and we can go to properties, we can set all of their y values to be the same. So the top was 200, so the y values will be negative 200, like so. Okay, and then this one, for mils, it's a let me just check something. 6.35. I think I typed this one wrong. Yeah, okay. So then we can just do the same x values as above. And I guess if you've noticed, we've been typing in millimeters, but then Altium automatically translated to mils. That's perfectly fine, and I actually think the units are nicer in mils than they are in this one when they're in millimeters. So we can basically reflect what we have here across the origin, and then we'll be done with the ports. But first we need to set the designators of all three of these. So if we look here, we have D4, G, and C. So we'll say D4, G, and this one C. Okay. Now maybe we can copy. So we'll do copy. Just set the center to be about the center, and then to scroll to the left, you want to press Shift and then scroll as you normally would. And we can paste, put them in about the right spot. Just so my properties panel disappeared, so we just go to panels and we select properties. You see that the correct height, and then this should be -50. This also should be -50. We can select these two, say properties, set them to be -150, and set these two, set them to be -250. And just make sure the height is correct. Okay, perfect. Now we just need to set the designators again. So on the top we have FAD1. So F A D1. Oh, not D, D1. On the bottom we have DP, D, and E. DP, D, and E. E. Okay. Perfect. Okay, so we have the most important part, which are the holes that the PCB will slot into. But there are a couple of extra nice touches that we can add. The first is we can put a box around where the PCB will sit, just so we have a sense of, like when we're laying out the board, kind of the boundaries of the actual component itself. So if we go back to the data sheet, we see that the board is 30 by 14. So we go to Altium. We can go to the top overlay layer. So this is what the silk screen will look like. So if you've ever seen a PCB and see kind of that white text on top, that's the silk screen. And so anytime you use kind of this yellow layer here, that's what you're drawing in Altium. So we can then go to this tool, we can select a rectangle, we can make a rectangle. This rectangle, we select it, we can go to properties, and we can reshape it. So we know the x is, well, actually let's look back here. The x is 30 millimeters and the y is 14. So we have the width to be 30, the width to be 14, and then millimeters, and this to be 30. Oh, sorry, it's the other way around. Um, 30 millimeters. And then we want this to be centered. Okay, like so. This is a little thick, so we can make the line a little thinner. I don't know, like maybe 5. Actually, no, we'll leave it like this. Okay. The other thing we can do is to help with the orientation, right? So as you can see, the pins here have different designators for the top and bottom layer, so rotationally it's not symmetric, but we need to make that clear to the person that's soldering this board together so that they don't accidentally solder it upside down. So something you'll notice about the board itself is that it has these numbers, but it also has the decimal. So we can use that decimal as a hint for the orientation of the board. So what we can do is, there's a couple of ways we can do this. We can probably do text, and we can type 8.8.8.8 dot, like so, and we can put it here. We can make it perhaps a little bigger. Oh, that's not gonna work. Properties maybe. Let's do text height, maybe 50. Wait, we just 100 possibly. We could do even a little bigger. And we can set the x and y to be 0, 0. Oh, so it looks like it orients by the bottom corner. So that's okay. We can just say for x, negative 15 millimeters, and then for y, we can say negative 7 perhaps. And that's wrong again. Probably because I did not account for the width. Okay, we can just place it by hand. Okay, so that looks about right. But now, when they look at the board, they know which way to orient it, which is good. Okay, so the next thing, you probably see this side panel here. We're going to say edit. We're going to name it, so the actual name of the 7-segment display. We'll use the part number, so it's CL. Actually, let's just check here. CL36. CL36 41AH. 41AH, and we'll say 4-digit 7 segment LED display. Okay. It's standard, I believe. The area, we can say, what is it? it's going to be square millimeters, and then it's 14 times 30, 420, and then the height is 7.2. Alright, this just makes it clear to whoever's using this in the future, kind of a quick snapshot of what your board actually does. The last thing that you want to do after you've put the text down to indicate the orientation is you want to place a 3D body. Extrude a 3D body, so you're going to select each of the corners and go here. And this purple thing just gives a note to the person designing the board that there's a 3D kind of component to this, right? So the board extends out of the PCB. Okay, cool. So then from here we can save. Cancel. Let's just save this one first. We'll just call it. We'll just call it ED. And then we'll just call this LED for now. Okay, so we've designed what the component will actually look like on the board. Now it is time to make what it looks like in the schematic. So we're going to say add new to project, and then we're going to say schematic library. All right, cool. So from here, we care a lot less about the dimensions here, and we just want a representation of the board itself. So we'll start with just putting down some sort of rectangle, like so. And we can change the properties around. It really doesn't matter, but fine, we can just do 30 millimeters and by 14 millimeters if we wanted, and then we can just place it at 0. Oh, okay, it aligns by the bottom left corner, so that's half of the x can be just 15, and this has to be negative, and this has to be negative 7. Okay, right, so we can certainly just lay out this rectangle, and this is just a representation of what it will, kind of looks like, but really you could make it a circle if you wanted. Matters a lot less. What does matter more is the pins, and just making sure that the pins are labeled correctly. And so we can rotate, and then we have 6 pins, so 1, 2, 3, and so okay, we'll just place a pin like this, like that. Actually, do one there, and there, one there. So to delete in Altium, you have to do function delete, like that. We do this. That doesn't look the best, so we can just select all of these and make them go higher. Maybe we can do this. Y to 7 millimeters, maybe. Yeah. just so they're on the edge. And then we can do the same thing for these ones. This is purely aesthetic. It really doesn't matter that much. It just looks a little nicer. -7 millimeters. Okay. Something that we do need to do, though, is we do need to change the designator. So, we just need to make sure that the designators, we just need to make sure that each of the designators exists. So, the bottom goes ED, DP, CG, DE4. Let's see if I remember that. So, we'll change it to E. We can just hide that. Go back here. We say D, DP. Let me just close this. D, DP, CG, and D4. So in properties, we're going to designator. Designator D. Hide the name. It's not really important. D4. Hide the name again. Oh wait, this is DP. C, G, D4, if I remember correctly. And just check. Yep. Okay. And then let's just hide this. Hide this. Hide this. Okay, up here. Actually, it might be easier if we just select all of these. And then just hide the names. Okay. On the top, we have D1AF, D2, D3B. So D1, A1, D1, and then we have A, and then we have F, and then we have D2, D3, and then we have D. Good question. Would be. Okay, we just double check. Okay, cool. All right. Once we've placed the rectangle, once we've placed the pins, I guess we can press add footprint. Before we get to that. Something to note is that these small white dots designate where the wire should be attaching to the pin. And that just has to do with when you're actually laying out the schematic. But yeah, so those white dots should be facing outwards and not inwards. That just would make a messy footprint. Okay, so now that we have all the pins and we have our rectangle and all that, we can say add footprint. We can call this what we... and we're just going to type in what we named the 3D one. So the name here, so we named it the serial number, so that's just CL3641. 36441. We look it up. That does not meet what we... Let's try to... maybe we can browse. Oh, okay, and it shows up for us. Okay, so we just, okay, that's what we want. Okay, and we see that, so that basically just links the footprint as well as the schematic. Cool. So from here we can save, call LED. It should save for us, hopefully. Maybe not. projects. Just do save. Oh, okay. We'll just call it LED. Okay, and then we can save the project as well. Okay. Now we can do a very similar process to how we integrated the Teensy. We just have to right-click, compile the library, and then when we go back to our schematic for our full PCB, we go place a component, change this to our LED library, and if we drag it in, that's what we see. Okay, so now we have 2 of the 3 components. The last one is resistors, which is quite easy. So let's take a look at the layout here. We look at this, just reset this here. We have resistors between some of these and the board itself, and then all of these pins will go through a resistor or won't go through a resistor, and then they'll end up going to a pin on the Arduino or on the Teensy. The pin that it goes to in the Teensy doesn't really matter. I mean, power and ground, that matters, but otherwise, otherwise we can just change it programmatically. In fact, the LED does not have power and ground, so we don't even have to worry about that. We can just send them to random pins, you could say, that are, you could technically send them to random pins, but that would not be the best. But I guess the point here that I'm trying to make is you could send these to any pin you want as long as they send out signal, and then you can change what those pins are programmatically when you're programming the Teensy to get the LED light to actually shine or show up. Okay. So if we look at the board here, we can, I guess, just start with D1. So we look at the schematic, D1's up here, and D1 through the breadboard does not get attached to a resistor, so we can press these tracks to place wire. Make sure it's red when you hover over it, and then we can send D1 to, let's see, if there's 6, you go 1, 2, 3, 4, 5, 6. We need to send it to pin 7, like so. Okay, now let's go move on to A. And we can change where this is located as such. So if we look at A does go through a resistor and then goes into another pin. So we need to replace a resistor. The actual resistance of that resistor doesn't really matter as long as it's the right size. So for this project, we're planning on using through-hole resistors. And so before this project, I did a little bit of research, and I basically just found a resistor that fits our needs. We're going to be using something called the 25FBF 52475R. If that shows up, yes. So we're just going to be using this resistor. I believe I need to download it first. Okay. And then yes, we can place it. So you have to download first. Okay. So then we're focusing on A here. So A comes out, goes into a resistor, and then into another pin. So you can press space to rotate. You can attach we'll just place the resistor up here, and we need to go to properties of the resistor. Okay, so comment, we can just hide this. We want to change the designator. It doesn't really matter. We just need a different designator for each resistor, so we just call it R0. And then we can place a wire between A and R0, and then we can place a wire between R0 and the TC. Okay. Then we have this one here. We can just delete that. Okay. Now to move on to F. You see the F has a resistor as well. So similar process. We could probably just copy and paste this one. And we'll just place it in the similar position. We will draw a wire, and again, the pins themselves don't matter as long as we set the pins to be correct in the code. Also don't know why I made this so tall, but it is what it is. The last thing to remember is change this name, this designator, just to a different resistor, so that when we convert it into a PCB, the computer knows resistor 0 is attached to A, resistor 1 is attached to F, blah, blah, blah. One benefit to setting these components to be, I guess, to look the same as what they actually do on the board is that if any wires cross when you're kind of filling stuff out here, then you'll know that wires will cross when you're putting it into the actual PCB form itself. So I guess that's one benefit to making the component schematics about the same shape as the component PCBs. Okay, so let's look at pin D2. Pin D2 is the third one. Is it the third one? Pin D2 is the fourth one, which is not attached to a resistor, and so yeah, it's not attached to a resistor. So we can just wire it directly. To a pin. Okay. I think it's a same story for D3. So wire, 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 wire. Okay. And then let's look at B. B does have a resistor. Now resistor, so we'll just place another like so. Make sure to change the designator and then just wire it. You need to make sure it's red so that it shows that the connection is actually there. Okay, that's one side, and now let's do the other side. Here we see that all of them are attached to resistors except for the last one on the end, which will be D4. So if we just put down a resistor, you can just place many of them, except for under D4. Okay, once we've placed all of the resistors, then we can start wiring, but I guess the first thing we'll do is just label them. So R3, R4, I don't know, this is all tedious, R5, R6, and R7. Now, I guess something to know about these resistors is they're probably not the right resistance that we're looking for, but again, it doesn't really matter. It's just that the footprint is the right size, so we can use it for this project if we wanted, which we do. Okay, and then we can wire. It just looks better if we do it this way and this way, that way, and then just wire them to the respective pins. So then when you're coding this, or when your teammate is coding this, you should have the schematic handy, just so they know which pin aligns to what pin on the 7-segment display, so that they can code it correctly. Okay. So that's the wiring there, and that's the resistors. Something to consider is if you want to put this on your robot, or like how you want this board to actually function. So right now the TNC is providing power for the 7-segment display through all of these various pins, but nothing's powering the TNC, right? And so something to know about the TNC is it has a port on it. It has a USB port, I believe, which you can power through, but if you're putting on the robot, then you're probably not going to use that power port, and you might use these VN and ground ports here. That's what we're going to do, and so to do that we'll need a terminal block, and that's basically just a block that you can screw wires into, and so in real life we would put that block on the board, and then we would screw the wires that come off of the VRM or something like that into those ports. So we need to place a terminal block. The one that I want to use is in the default Altium library. It's called, or it has the part number 1729128, if I'm correct. Yeah, it looks like this. Again, I think we'll have to download it, which is fine, and then just drag it in. Oh, okay. Good. Just drag it in. Okay. Okay. And then we will attach them as follows. I don't know. I just arbitrarily, we can just say 1 goes to VN. And then something to note about ground ports is that you just add one of these ground pins onto them. Space to rotate, by the way. You just add a ground pin onto them because ground is special. Okay, so we've successfully wired our component. I guess a couple of things to remember when it comes to Altium schematic design and I guess PCB design. You care less so about the actual resistance and stuff, and more so whether or not the components will fit in the right holes and kind of hole sizes and hole distances or surface pads. sizes and surface pad distances, so that's why we can use these resistors. Something to know is use ground pins instead of like wiring the grounds together and stuff like that. It's because ground is special and it's whatever. But yeah, so this is our schematic, so we'll just save it. Actually, maybe we should save the project first. So we'll save this. We'll call it, what is this? 4-digit 7-segment display. Cool. So we've made the schematic. Now it is time to make the PCB side to it. So we're going to go here. We're going to say add new to project. We're going to say PCB. Okay. That takes us here. We need to go to design and then import. Oh, we're going to need to actually save this file first, and we're going to name it 4-digit 7-segment display. And then we're going to say design import. I want to say validate, execute those changes, and let's close. Okay, so we scroll over, we see this. So these are all of our components, but the actual PCB form. So this is what it would look like on the PCB. Remember, yellow is kind of the outline on the top layer. These pinkish layers are kind of showing that there's a 3D component, and these holes here are an indication of, I guess, holes that will be drilled into the board, so we can plug our components in and then solder them in. The first thing you do, whenever it imports, it gives you this weird pink film. I always just delete it. That's function delete. And then we can start to kind of lay out the order of this board. So let's think about that. Sorry, just charging my computer. Okay, so usually, let's think about the terminal block first. The terminal block will go on the edge of a board. That just, I mean, it won't go in the middle because you need it like snake wires onto the side of the board itself. So we can just say that maybe this is the edge of our board and then have our terminal block there. Then we can, then if we think about kind of where the wires are going, the power is going straight from the terminal block to the TNC, right? That's kind of what these lines represent. And so we can kind of lay them out like so. From there, the TNC is sending signal to the resistors and to this board itself. And so we probably want to lay it out very similar to how we laid it out in our schematic, just so that the wiring works very nicely and no wires cross and stuff like that. So to rotate this, we need to go to properties and then change rotation to perhaps 180 and just kind of see what that looks like. This is upside down, so we can change this to 0. And that is better. Okay. And then we can move these resistors down under. And these resistors above. Oh, and then to zoom in, you just press Control and you can scroll. You can use more precise positioning if you'd like, but this is a little more casual project. It can be, as long as it looks good to the eye, it's okay. Can make this a little closer. This is kind of a subjective part to the project where you just kind of choose what looks good. Okay. Because all of the resistors are the same, I'm just going to delete these resistor labels. I'm going to delete this label, these labels. I'm going to delete all of these labels basically. If I can. Whoa. Maybe just hide. Oh. So, hide all of them. Okay. Once we've done that, we can maybe make this a little closer. Something like that. Alright, perfect. So, the next thing we'll do is we'll just kind of, and this is personal preference, we'll just put all of our components closer to the origin, like so. Okay. So you might have noticed this big black board just kind of floating in the background. That is what the actual outline of the PCB, that's what Altium thinks is the actual outline of the PCB. That is not correct, and so we need to change that. And so what we're going to do is we're just going to make a rectangle that goes around our board. And we can change it a little bit just to make it the right size. Okay, like that. And then we will go to design, I believe, board shape. Actually, wait. First, let's move all of this so that the corner of the board is like that. Okay. Then we can go to design. Oh, wait. We need to select the rectangle, go to design, board shape, and then define board shape from selected object. And we can delete the rectangle then. So that's what our board will look like. Now here's the fun part, maybe. We're going to wire the PCB. So Altium makes it really easy in that we wired it on the schematics, and so now you see these kind of traces or these lines that wire between the between what components need to get linked together. Something to note is you're not going to wire any ground, because at the end we'll do a ground layer that will include all of the ground ports. So let's get started wiring. We're going to do interactively route connections, and then you're really just going to pick one using control scroll to zoom in, and wiring between needed components. Something to note is you can go under components because the board is under the components themselves, which makes things easier for sure. But yeah, wiring is pretty easy. You just follow the lines. And because we laid it out in Altium in such a way where no wires cross, we won't have to use the bottom layer. So we see that we've kind of run into the bottom of our board. And so what we might have to do is make the board bigger. But let's wire these top ones first, and then we can do that. We can take advantage of the fact that we can go under components to wire things like this. And then maybe this will fit. It's a little too close. Okay. So then we'll just snake up here. Go like so. Okay. So we have wired everything except for ground. It is a little bit too tight on the bottom, so we can just select everything and just move it up a tad. And then we need to redraw a rectangle using this tool, rectangle tool, around our board, which could be a little like that, a little taller just to give space, and then definitely make it. Okay. So then if we select everything, we can just kind of put it back on the origin, and then we can select our rectangle and say, select the rectangle, go to design, board shape, define board shape. Perfect. And then just delete the rectangle. Okay, so then now we can lay the ground layer, which will connect all the ground. So to do that, we'll do polygon pour. We're going to want to go to each corner and select it. Sometimes it's easier to just zoom out and then zoom back in. Smaller. Let's just select right here. Oh, we're going to have to redo this one. I messed that up. Let's do polygon pour again. Let's zoom in. The corner. Select the corner. The corner. And then select the corner. Press escape. Okay. So then, this creates a pour. We're going to go to properties. And you're going to want to select a net. You're going to choose the ground net. And then you're going to say re-pour the polygon. And now, if you'll notice, close properties. Now, the ground layer avoids all these other wires, but then attaches to the connections that need ground. So that's our whole ground layer, and all of our grounds are covered. Okay, perfect. So, this is an orderable PCB. This is great. But I do think there are a couple of things that we can add to make it a little bit easier for people to kind of work with it. So all of the resistors are the same, so there's really no need to kind of differentiate between the two. We know what this piece is here, and we know what this piece is here, just because our team has worked with teensies, and this is our standard for teensies. And then the board looks like the actual LED display. But for here, I do think it's worth labeling which one is 5 volts and which one is ground for power input. And so to do that, we just can place some text. Oh yes, place some text. Actually, let's see first. Let's go to top overlay, right? So this will be printed on top of the board, and then we can place text. We'll just put it here, and change the string to say ground. Something like that. And then on the bottom, we can also put some text. I'll just make it say 5. Oh, let's change this. 5 volts. Like that. The other thing, so if you think about it, this will be covered by something. This will be covered something. These will be covered by something. We can also customize the board a little bit, but I do think it's nice if we just put like some strings of text here that just say, you know, 4-digit 7-segment display to see, or maybe no, we'll just say like Peter C, right? It gives a little bit of personalization, but it shows like, oh, I made this board. Properties, let's make this like 90. I'll just put it right up here. But you can definitely personalize it a bit. I know I've had some teammates like draw Among Us's using like the line tool and stuff like that. But yeah, you can really make the board yours. Once you finish making the custom designs on your PCB silk screen, the last thing you need to do is create one rectangle that goes all the way around your board. So we'll do this like so. And then in properties, we'll change this to a keep out layer. This is so that the designers know what the edge of your board looks like and kind of knows where to cut there. Sorry, when I mean designers, I mean the company that we're going to send it to. So once we finish the design, we can start to export this file into files that a machine can understand to cut out the board. And then we'll send those files to the manufacturing company, and they will cut out the board. So we just drew this line around, or this rectangle around, so that the computers actually know where to cut the board. So we'll start by saving our thing, our PCB file. And then from there, we'll go to File, Fabrication Outputs, and select Gerber files. We'll start with general. We can keep units as inches, and then we can keep the format 2 to 5. Layers wise, we want to choose everything but the mechanical layers. And then drill drawing, we want to choose top and bottom layers, these two check marks here, and we don't care about the other two. That's great. Once you press OK, it'll generate a file that looks like this. And from here, we'll go File, Export, and then Gerber. Press OK, and then we want to send it to the folder that you're saving everything into a file called Gerber. Let's try that again. We'll go File, Export, Gerber. We'll press OK, and then we just need to go here. We do Select Folder. Okay, and we'll generate all those files. Next, we go back to our board. We do File, Fabrication Outputs, NC drill files. We can keep all the defaults. Press OK. Press OK here, and then we'll get a drawing that looks like all the holes. And this is the file that tells the computer where to draw or the machine to drill all the holes for our PCB. From here, we'll do a very similar process where we'll go to Export, Gerber, OK, choose the same folder, and export there. Once we've generated all of the Gerber files, we can go where we're saving that folder. We want to send it, and we want to compress the folder. We can keep it named Gerber, that's fine, and just double check that everything's there. Cool. So we have our zipped folder with Gerber. This is what we're going to be sending to the company. Our team uses Washpark. And so from here, let's just do Browse Files, choose the zipped folder, press Open, just wait. And then from here, we can just double check that this is indeed what we designed. We do not have a bottom silkscreen layer, but that's okay, because we didn't design one. Then we can just double check that everything looks correct, and then we can order. All right, thank you for watching this tutorial. I know it's a bit long, and I'm sorry for that, but I hope it was educational.